In this video, we're going to look at uniform circular motion, which is why and how things move in a circle and kind of the physics that we use to describe that. So first of all, with uniform circular motion, by definition, it involves an object traveling in a circular path with a constant speed. And so that just comes from breaking down this phrase up here. So circular motion, hence the circular path. And then uniform, that's where we get that constant speed. And so something to note really quickly here is that it does not have constant velocity. Notice we said speed, but not velocity, because the direction is constantly changing. If you're moving in a circle, you're not moving in a straight line. I know that seems pretty obvious, but if you imagine at one point you're moving in this direction, then a second later you kind of turn this way, then you kind of turn this way, and a circle is ultimately you're always changing directions and pointing in a different way. And that's how we get this idea. So we don't have constant velocity, but we do have constant speed. So in order to have that situation where we have a constant change in velocity, that means we also have to have a constant acceleration. Because remember, acceleration is defined as the change in velocity divided by the change in time. So if we're constantly changing our direction, we're constantly changing our velocity, we have an acceleration. And this is known as centripetal acceleration with a P. Centripetal acceleration. And it comes from Latin. It roughly translates, or the roots that it's using roughly translate to center seeking. And that might help you remember it. In other words, the centripetal acceleration is always pointed towards the center of the path. And you can calculate it as AC equals V squared over R, where R is the radius of the circular path and V squared is the speed squared, and this tells you how much it is. And something that I had mentioned earlier that I want to reiterate here is centripetal acceleration is always pointed towards the center of the circle. So by definition, what's causing you to go in a circle is the fact that your acceleration is always pointed in towards the center. We also have a centripetal force, so we know that acceleration is the result of a net force. So the force or combination of forces that cause our centripetal acceleration is therefore known as centripetal force. So that kind of makes sense. We're going to share the same words here. And this is, let me just double check here. Oh yeah, the acceleration or the equation for this is that the centripetal force equals the mass times the centripetal acceleration. Or if you prefer, you can also write, so let's write an or here. Fc is equal to mv squared over r, where we're just substituting in what we know to calculate for AC squared. This centripetal force is also always pointed towards the center. So if you have a centrifugal acceleration, the force has to be pointed in the same direction, so it will also be pointed towards the center. So let's talk about a couple examples of this. Because centripetal force is a little different than what we've talked about before. It's better understood as a description rather than a type of force. So we talked about a bunch of different examples of forces before. The spring force, the gravitational force, the normal force, the strong nuclear force. Those are all kind of types of forces. They're the result of interactions of objects. This can be any one of those forces we mentioned before. So for example, if a satellite is orbiting the Earth in a perfectly circular orbit, the centripetal force is due to the gravitational force. Or in other words, we can think about instead saying the gravitational force in this instant is a centripetal force. It is a force causing circular motion. If I've got a little toy that I'm kind of spinning on a string above my head, then Fc is due to tension force. Or we could also say the tension force in that example is a centripetal force. It is a force that causes circular motion. If you have a car driving in circles, like they like to do outside my apartment at 2 a.m., then we say that Fc is due to friction. Or in other words, that in this case, the frictional force is a centripetal force. It's causing circular motion. So a couple of trends that we need to note. If you remember, we had the equation Fc equals MAC equals mv squared over r. If you have a greater speed, if you want this speed to be bigger, then the radius and or force need to be bigger to keep it in a circle. So if you want to go faster, either you need to go into make a bigger circle, or you need to have something pulling harder on it to get that greater acceleration. And this can be force or acceleration, because they're kind of, in this case, the same things, because the force is causing an acceleration. If you want a smaller radius, then you need either slower speed or smaller force / acceleration. And there's all sorts of other combinations you can talk about here. If you want to have the centripetal force be larger, then you might have to increase the velocity or decrease the radius. It's all about looking at kind of these relationships here and just kind of imagining if Fc is going to get bigger, what can I change on the right side here to make this thing bigger? And that's just what we're looking at here, is broadly kind of big figures here. And I'm realizing I missed something in the guided notes. So this is a little bit as an aside, that if you've ever heard of centrifugal with an F and a G, centrifugal if you prefer, centrifugal force is not the same as centripetal. I know they sound very similar and they're spelled very similar, but the FG versus the PT makes a big difference. Centrifugal force, this here is a fictional or if fictitious is the better way of phrasing it. Fictitious / imaginary force. So it doesn't actually exist, but I don't want to say that in the sense of it's something we never talk about. It's just not something we'll talk about in this class. It's imaginary sort of in the same way that imaginary numbers are imaginary, meaning they're useful and they do serve a purpose, but they're kind of different in certain ways. And if you're curious, talk to me about it, but otherwise I just want to point out we shouldn't use it. We're not talking about it in this class, and so I just want to make that distinction here.